Infinite limit is a limit that increases or decreases without bound as x approaches a number. In this case, we use a as the number. Okay, let's just write. It is a limit in which f of x, that's the function, increases or decreases without bound as x approaches a. That is mathematical. This is written limit of f of x as x tends to a is equal to positive or negative in infinity. So that's the meaning. So let's look at the diagram so that you see what we. So the first one is the left hand limit. So limit of f of x as x tends to a from the left is equal to, as you can see, is increasing without bounds, so it's positive infinity. Positive infinity. While the second one, as x approaches a from the right, that's why it's positive here. F of x also increases without bound, so also positive infinity. So this, the third diagram, you can see as x approaches a, as x approaches a, f of x from the right, yes, f of x decreases without bound, that's negative infinity, y same as approaches a from the right, f of x decreases without bound. So here, the same logic, the limit of x tends to a of f of x will be positive infinity. You notice here I didn't put negative or positive. Why? Because both the left and right will give us positive infinity. So you can remove the sign. Yes. Why here? The limit of x tends to a without, that's both left and right, as you can see, will give us the negative infinity. So that's why I didn't bother putting plus or minus. So, and there's what we call vertical asymptotes. So if x, that the line x equal to a is called a vertical asymptote of f of x if at least one of the limits exists. So if f of x increases or decreases without bound, then that number x tends to, x equal to that number is the vertical asymptote. So if one of them, this limit exists, then x equal to a is called the vertical asymptote. From the diagram, this line, the line you are seeing, the dotted line, that's what we call vertical asymptotes. That's x, the line x equal to a. So let's look at this question. For the function f whose graph is shown, state the following limits. So let's state this following. Let me just use another page. Okay. We're starting, they say limit of f of x as x tends to -6 from the left. So c -6, do you see vertical asymptote? And f of x is tending towards that. So what do you notice? It increases without bound. So this should be, is now positive infinity. So yb is approaching from the right. See, it's decreasing. without bound. So this is negative infinity. Y without sign. It does not exist, yes, because the left and right hand limits, they are not the same. So this does not exist. So this is D, and it does not exist. Why? The limit of f of x as x tends to a exists, as is equal to L. It exists and is equal to L if and only if the left and right hand limits, that the left is equal to the right, and both of them is equal to L. So if both are equal to L, then the limit exists. That's the meaning. And it will be equal to the value, the answer. That's both of them. So here we have positive, we have negative infinity. So positive and negative are not the same. So the answer is does not exist. YD approaching -2 from the left, we have negative infinity. So we have, this is negative, is negative infinity. Y here, also from the right, the same negative infinity. So making this to be negative infinity, yes, because both are the same. So both the left and right, they are the same. They give us negative infinity. So this will give us negative infinity. For 2, f of x as x approaches 2 from the left, as you can see from the graph. So this gives us positive infinity. Y from the right, also positive infinity, making this to be positive infinity because both of them, both the left and right hand limits are the same. So that gives us positive infinity. So for the asymptote, vertical asymptote 6, as you can see, f of s is decreasing without bound, both from left and right. So this is negative infinity, negative infinity. So both of them, since they are equal, it will give us negative infinity. So that's all for infinite limits. So whenever a function is increasing or decreasing without bound, then the limit, we have an infinite limit. Thank you.